Okay, let's do another one. Find the derivative of f of x is equal to negative 5x plus 2. So I like breaking this up, okay? I like finding just f of x plus delta x because sometimes there's a lot of simplifying that we'll have to do. Right now, not so much, but eventually we will. So we replace x with x plus delta x. Okay, let's go ahead and simplify. Distribute the negative 5. Doesn't do a whole lot in this case, but you never know. Okay, we can't combine any like terms. We got to leave it. That x and the delta x are different terms. Okay, so let's do this. F prime of x equals the limit as delta x approaches 0. Now I'm not going to write just the general form this time. I'm just going to jump into plugging in my pieces. So here is f of x plus delta x. That's what we just found. Minus. Here's why we need the parentheses. When there's more than one term, you gotta apply that negative to both the negative 5x and the 2. And that's all over delta x. So let's work on simplifying. Okay, we've got negative 5x minus 5 delta x plus 2. Apply that negative. I went ahead and took an extra step here to do that, just so there's no confusion. So the plus 2 and the minus 2 cancel, the minus 5x and the positive 5x cancel. I know you can see that the delta x's cancel at this point, but let's go ahead and just write it again, just so that there's no confusion as to when we cancel that delta x. It's in this step that we can cancel those. So this one ends up giving us the same thing, negative 5. But the reason is negative 5x plus 2 is still a straight line. It just has a y-intercept of positive 2 instead of going through the origin. So it's still going to have a slope of negative 5 everywhere. So derivatives of linear functions, pretty boring. So let's look at a polynomial. Let's look at negative 3x squared minus 5x plus 3. So let's start with f of x plus delta x. This one's going to be a little bit more involved. So everywhere we see an x, we replace it with x plus delta x. Okay. What happens when we have x plus delta x squared? We don't just square each of those things. We've got to multiply this by itself, which is going to require FOILing. Okay. So I went ahead and took the step just to write it by itself. I'm going to go ahead and distribute the negative 5, because why not? Why waste an entire line? Okay. Now, I say distributing the negative 3 to the end. Okay. X times x is x squared. X times delta x, we just got to leave it. And then we get another one on the inside. So we have 2x delta x's. Okay, that's how we write that. X times delta x, it's like xy, okay? Plus delta x times delta x, well, that's delta x squared. And you really don't need the parentheses, but I put them there just for clarity. Okay, nothing else has changed with the rest of our problem. Now we can distribute the negative 3, negative 3x squared minus 6x delta x minus 3 delta x squared, and you know what, I'm going to drop the parentheses because we really don't need them, minus 5x minus 5 delta x plus 3. Now, it'd be great at this point if we had something that were like terms, but nothing is exactly the same. So we've got to leave it in that form. So let's go to our limit definition now. F prime of x is equal to, the derivative is equal to the limit as delta x approaches 0 of, get that big old long expression there for f of x plus delta x, minus f of x all over delta x. Now, since we're in the beginning stages of this, I'm trying not to skip steps at all, so I'm probably going to end up writing more than we really need to, but it can never hurt to be careful, because the longer I do this, the more I see people making careless mistakes with negatives and the such. So it never hurts to just take that extra step. I know you don't want to write more, but to actually show distributing that negative. Then we can go through and we can cancel some stuff. Negative 3x squared, positive 3x squared. Negative 5x, positive x. Positive 3, negative 3. Well, that was nice. A whole bunch of stuff just disappeared. So let's look at what I'm going to change colors, and let's look at what we've got left. Negative 6x delta x minus 3 delta x squared minus 5 delta x. And that's it. That's all we're left with. Now, it was at this point where in the last problem the delta x is canceled and we were done. It's still going to happen here, but it just takes a little bit more work mathematically on our part. All those terms in the numerator have a delta x, so factor that out. So we're left with negative 6x minus 3. That one still has a delta x because it was delta x squared originally. So now it's delta x minus 5 all over delta x. Here's where you can cancel those delta x's. Okay, don't try and do it without factoring it out because you'll mess something up. Trust me, I've seen enough people do it up to this point. So we don't have a problem anymore. If we had tried to plug in 0 for delta x before this point, we would have been dividing by 0. So now we can plug in 0 for delta x, and here is our derivative, negative 6x minus 5. Negative 6x minus 5. Now, it was a little bit more clear that we had the right answer in the last problem because they were, or in the last two problems, because they were linear functions. Their slope was the same everywhere. But with polynomial functions, quadratics, cubics, quartics, the slope changes depending on where you are on the function. Sometimes it's steeper, sometimes it's not as steep. So that's why our derivative still has a variable in it. It depends on where you're at. If you're at x equals 3, you're going to have a different slope. If you're at x equals 0, you're going to have a different slope. If you're at x equals negative 7, you're going to have a different slope. So that's what the derivative allows us to do. It allows us to find the slope of the tangent line. Let's write that out in our notes. The derivative equals the slope of the tangent line at any point. At any point. Okay? If you want to find the slope at a specific point, then you plug that point in. But the derivative itself gives you the slope of the tangent line at any point. That's what the derivative is. So I've got some problems in the textbook that I want you to work on with finding the derivative of these polynomial functions, and then we'll look at some more difficult functions later on.